Hi students, today we are going to discuss the topic of composite materials. This is the fourth unit of engineering metallurgy. What is a composite? Composite is a material which is contained of two distinct phases. It is a heterogeneous mixture. Namely, we can call it as fiber and matrix. These two together we call it as a composite materials. Example, we can take the composite materials, our concrete, building concretes. A building concrete consists of fiber is a we call as a fiber, we call as a steel, and matrix we call as a cement, and with the sand this we call as a matrix. Together we get a composite. Composite is a material we call as a heterogeneous mixture. For the past 70 years, the technology of design and manufacturing and utilization of composite have been increased. From 1930 to 1990, there is a huge improvement in the composite materials. Initially, they start with phenolics and they use for epoxies and fiberglass boards. Now, fiberglass boards are started in 1945 itself. They started for manufacturing the fiberglass boards. Then they use for glass and epoxy circuit boards. Then nowadays they are using for Kevlar. Kevlar fibers are mainly used for defense applications for armor jackets. These are the general application of why we are going for composite material. We are going for composite material is first we are going for composite materials for because of lightweight. We have to reduce the weight of the material. Why we have to reduce the weight of the material? In automobiles, if you use for reduce the weight of the material, the efficiency of the automobile will be increased. The efficiency of automobile will be increased by manufacturing some parts with the composite material. Example, in this automobile car, they manufacture with the thermoset plastic composite materials for this window shields. Then we use for super plastics. Then we use for metal matrix composites. There is a two distinctive phase we call as a metal matrix composites and we call as a fiber based composites. The metal matrix composite they consist of metal is a major element with added with some reinforcements. Classification of composite materials. The composite materials are classified into three parts: particularly reinforced and fiber reinforced, structural. This reinforced we called as a fiber material. Reinforcements we call as a fiber, right? Always in composite material, the matrix will contain a large portion, reinforcement will contain small portion of the composite. Example, if you take 100% of composite material, the 60% of will be contained as a matrix and 40% will be contained as a reinforcement agent. Now we have a particularly reinforced composites are classified into two types. One was a large particular and another was a dispersion. Then fiber is converted into two types. It's called continuous and discontinuous fiber. Then structure we call as a laminates and sandwich. The laminates will have a layer by layer. We call as a playwoods. Playwoods are called as a laminates. Continuous and discontinuous. Discontinuous will be two forms. One will be aligned and another will be randomly orientation. These are the very important of classification of composite materials. Again, classification of polymer composites. Polymer composites are consist of two parts, as I said that previously, matrix and reinforcement. Matrix will be a major part of the composite material. Reinforcement will be called as a minor portion of the composite material. In the matrix they use for thermoplastics and thermosetting plastic. Example of thermoset plastics are given below. Thermoset plastics are epoxy, polyethylene and polymers. Again, reinforcements are classified into plastic fiber, carbon fiber, glass fiber, and then even though nowadays they use for ceramics and metal powder. Metal powder in the form of cut wire powder. These are the general characterization curve for composite material. As we have seen that the tensile strength of stress versus strain. The strain contains an x-axis, stress contained in y-axis. We have contained the tensile test. The fiber will have only a large portion of tensile strength and the resin will have a small portion of strength. Together we get an optimum composition of tensile strength is called fiber reinforced composites. Example, the mass reduction. Mainly why we are going for composite material. The composite materials are weight reduction. You have to reduce the weight of the object. You have to replace the aluminum alloy or steel with a composite material. Example which is given, a carbon fiber composites are material replaced for steel aluminum cast iron. The mass reduction will have a 50 to 60%. There is a huge reduction of mass. If mass is reduced in automobile or any different structure applications, the efficiency will be improved. Based on the orientation of fiber, right? There are three types of orientation of fiber: aligned fiber, random fiber, and random fiber. These are the different fibers which can be classified. The properties of composite materials are unique to particular composites because they are called as anisotropic material. In the anisotropic material, the properties are mutually perpendicular direction. In alloys, we call as isotropic material. The property of the material can be varied from 1-to-1 phases, but in orthotropic material, the mutually if you take in X direction, the strength will be vary, and Y direction, other strength will be vary. In isotropic material, the single direction you can take it as composite. Single direction you can get a tensile strength. As I have discussed previously, the continuous, discontinuous, and random.